Ever wonder why AI sometimes makes things up? Let's dive into the fascinating world of LLM hallucinations. Hello everyone and welcome. Today we're going to explore a critical topic in the world of large language models, hallucinations. What are they, and more importantly, why do they happen? At their core, LLM hallucinations are instances where the AI generates information that is factually incorrect, nonsensical, or contradicts its training data or the real world. Understanding hallucinations is crucial for anyone using or developing LLMs, from researchers to everyday users. It helps us build more reliable AI and use these powerful tools more effectively. One of the primary reasons LLMs hallucinate stems from inherent knowledge gaps. These models, vast as they are, don't possess all possible world knowledge. The sheer volume of human knowledge means no training corpus can encompass everything. LLMs are trained on massive datasets, but even these have boundaries and limitations. Furthermore, even within their training data, it's challenging for LLMs to grasp the long-tail knowledge, the less common, niche, or highly specific facts. This often leads to gaps where specific information is needed, but not adequately learned. Therefore, LLMs inherently possess knowledge boundaries. If a prompt requires knowledge beyond these boundaries, the model might attempt to generate an answer, even if it has to invent it. This creates a crucial gap: the knowledge expected by the input prompt versus the knowledge actually embedded in the LLM. When this gap is significant, hallucinations are a common outcome. Another significant source of hallucinations is the noise present in training data. This noise can introduce errors and misinformation directly into the knowledge stored within the model's parameters. Training data, especially when sourced from the vastness of the internet, inherently harbors misinformation, biases, and inconsistencies. When an LLM learns from such data, it can inadvertently internalize these errors. This issue becomes even more serious when training on massive, large-scale corpora. The sheer volume makes it incredibly difficult, if not impossible, to perfectly filter out all the noise and inaccuracies. Despite advanced filtering techniques, some level of noise will always persist in pre-training data, leading to the potential for the LLM to generate creative but incorrect responses when faced with ambiguous or flawed inputs. So, to recap, LLM hallucinations are a complex phenomenon, but they primarily arise from two core issues. First, the inherent knowledge gaps within the LLM's training data, meaning they can't know everything. Second, the unavoidable presence of noise and misinformation in the vast datasets they are trained on. Understanding these causes empowers us to use LLMs more responsibly, to be critical of their outputs, and to develop strategies to mitigate hallucinations. By recognizing these limitations, we can harness the true potential of these powerful tools.